Um, we're solving equations that contain rational expressions. And just so you know, so I'm recording this, and you'll be able to see this. But we've got a test with this. This finishes chapter 7, so you want to make sure that you are prepared for the test that I've just posted as well. All right, and I'll send that out as an announcement. So everybody can. Okay, so solving rational equations. So let's start with something like this. Solve there's when we talk about rational equations, we're talking about equations that have fractions in it. Okay, and so this one doesn't really have rational equations. It doesn't have variables in the denominators. But the method that we use to solve this kind of equation is going to be used to solve the rational equations. Basically, what we do is we first find the LCD. What would the LCD be here? 18. We look at the 6, the 3, and the 18. And so the least common denominator would be 18. So we're going to multiply this left side by 18 and this right side by 18. Actually, 18 over 1, right? And so let's do the right side first. Because look what happens. Yes, I get 18x over 18 times 1, right, when I multiply. But then the 18s will cancel out, right? And more often what I'll do is I'll just imagine the 18s canceling out and all I'm left with is an x to begin with. So I save myself some time. The reason I multiply by 18 is because that fraction should disappear. And that's why I do it. I want the fraction gone. And so that's the same thing I'm going to do on this left side over here. All right? We're going to multiply that 18 through, and it's going to require us to distribute it, right? So we'll take 18 over 1 times x over 6. Now let's just talk about that for a second. When I take 18 over 1 times x over 6, notice the 18 and the 6 have a common factor of 6. 6 will go into itself once, and 6 will go into 18 3 times. So basically what's going to happen is this 6 is going to cancel, that's going to cancel and leave a 3, right? So all told, all I'm left with is a 3x, right? Because it's 18x over 6. And we'll put that middle step here and here for the first couple times. But once we get used to it, we'll just jump right there because we know that's where we're going. All right, now let's take the 18 over 1 times 4x over 3. And so we do 18 times 4, that's 72. 72x over 3, right? That boils down to a 24x. But again, the way I do it typically is I just say, hey, look, a 3 is going to cancel from there. 3 will go in there once, 3 will go in there 6 times, and then I'll have 6 times 4x. So there's my 24x. But the whole reason we do this is because, look, now we end up with an equation that has no fractions, and we can just solve it like we have always done. Right, so we combine our terms to get a 27x equals x. We'll subtract the x over from both sides. We end up with 26x equals 0. So that tells us x must equal 0. Okay. All right. Let's do another one. But let's do one that involves rational expressions. So one that involves terms in the denominator, variables in the denominator. So we want to solve 2x over x plus 2 minus 2 equals x plus 8 over x minus 2. Okay, so you can see fractions, rational expressions. All right, so the method we're going to use is we're going to look at all the fractions and we're going to say, what's the common denominator? And of course, the common denominator is going to have an x plus 2 in it and an x minus 2 in it. So the LCD is x plus 2, x minus 2. All right, so we're going to multiply by x plus 2, x minus 2, x plus 2, x minus 2, right? I need parentheses around this. Now, let's do the right side again because it's easy. Now, just notice when you multiply the right side, this x minus 2 and this x minus 2 are going to cancel. And so what you're left with, because one's on the top and one's on the bottom, what you're left with is x plus 8 times x plus 2. All right? That's on the right side. Now, on the left side, I take x plus 2 times x minus 2, and I'm first going to multiply it by this and then by this. When I multiply it by this guy, the x plus 2's are going to cancel. One from the top, one from the bottom. So what we're left with is a 2x times x minus 2 minus 2 times x plus 2. Nothing cancels when we multiply by 2. But notice, all the fractions are gone. That's where we want it to be. And so now we can solve this. And of course, to solve this, we know we got to multiply everything out. 2x squared minus 4x minus 2 times, let's see, FOIL this out, x squared minus 4. This right side is x squared plus 10x plus 16. 2x squared minus 4x minus 2x squared plus 8 equals x squared plus 10x plus 16. Alright, so we just kind of keep working this through. This is a minus 4x plus 8 equals x squared plus 10x plus 16. Alright, we've got to get, so this is a quadratic. You see that x squared? And so remember, with quadratics, you have to move everything to one side so that we have 0. So I'm going to add 4x to get rid of that, and add 4x there, subtract 8, and subtract 8. So that leaves me a 0 there. Gives me an x squared plus 14x minus 2. Right? And that is our equation. Just looking real carefully here. Just want to make sure I didn't miss something. I'm feeling, oh, I am. Okay, I'm going to back up. I hate to do this to you, but we're going to have to do it. I'm going to have to back up all the way here. I copied it wrong. That's not x plus 8, that's x minus 8. Okay, so that should be x minus 8. So that changes this. It changes this. I'm just gonna cross them out. And this. So I've got a minus 6x minus 16. If that's a minus 8, that changes this to a minus 6x minus 16. Minus 6x minus, and where the heck did I even drop that? Minus 16. Wow, I was way off. This is the advantage of when I have you guys there in the class to catch these. So we're okay. It'll be an x squared we've got a minus 6x minus 4x, which is a minus 2x, and a minus 16 minus 8 is a minus 24. There we go. My apologies. But there we go. There's our quadratic. We can now factor it, right? Because remember, that's how we solve quadratics. Looks like it's going to be x minus 6 and an x plus 4. Set each of those factors equal to 0. X equals 6 and x equals minus 4. And so there's our two solutions, right? So a little bit more work involved there. But hopefully, you know, once we eliminate those fractions, then we have just a regular equation to solve. Let's do one more here. So let's solve this one. We'll just jump in and do a tough one, right? Those other ones are so easy. 1 over x plus 2 equals 4 over x squared minus 4 minus 1 over x minus 2. All right. So we're going to multiply by the least common denominator. But one of the things that we know, that we've learned, is if I want to find the least common denominator, I have to factor all the denominators that I have. So this x squared minus 4 needs to be factored into an x plus 2 and an x minus 2. And then that's the only thing we need to factor. But once it's factored, now I can find the LCD. And I look at those and I say, oh, my LCD's got to have an x plus 2 in it and an x minus 2. So that's my LCD. That's what I'm going to multiply by. X plus 2, x minus 2. X plus 2, x minus 2. All right? So when we multiply that through, let's do the left side first. The x plus 2's are going to cancel. Bam, right? One from the top, one from the bottom. And that leaves a 1 times x minus 2. Okay? 1 times x minus 2. Hold on 1 second here. Okay, now let's go to the right side, and we're going to take this times this. Now notice these are both on top over here, so they're going to cancel with both of those on the bottom, so they're going to disappear. So we're left with just a 4. That's really nice. Minus now do this times this. And what's going to cancel is an x minus 2 on top and x minus 2, or an x minus 2 on the bottom. So we're left with a 1 times x plus 2. Okay? And so there it is. All the fractions are gone. We can now solve that thing. X minus 2 equals 4 minus x minus 2. And we just, let's add x to both sides. So that gives me a 2x. Where are you going here, folks? Shasti, are you still there?
Yeah.
Okay, I don't know what button I pushed. We're going to add add x. And add x. So we get a 2x minus 2 equals 4 minus 2. We might as well call that 2. And we will add 2 and add 2. So we end up with a 2x equals 4, or x equals 2. Now, here we see for the first time a challenge that we have with these, and that is when we've done everything correct and we get down to this point, we get a solution. You always have to check your solution to see if it really even works. See, when we solved equations in the past, we would check a solution because it was a good, smart idea. It was just a smart thing to do. But when you're solving rational equations, you have to do it because what actually happens is sometimes you get a number that's actually not a solution, even though you've done everything correct. So if you go back here, look at this equation. If I try to plug the 2 in, look what happens. I will get, in that one right there, 1 over 0. That is undefined, right? Because it creates a 0 in the bottom. So 2 is not a solution. And since that's the only possible solution that we had, this particular equation has no solution. We call this an extraneous solution. It's not a solution to the equation, right? And you have to go back and check. And in fact, when you first start a problem, right, when you're way back up here and you factor the thing, you can just look at that and you can say, hey, I know -2 won't work because -2 will create a 0 there, and a 0 there, and therefore a 0 there. I know 2 won't work because it'll create a 0 there and a 0 there. So before you even do any work, you know that plus and -2 are not going to work. And you know that with all of these rational equations before you do any work. All right? Okay. So Shasti, there it is. There's a couple examples of solving rational equations. Now remember, you've got lots of other materials. If you want to see more examples, you've got other lecture materials. But I wanted you to see a couple examples. Does that make sense? Do you have any questions on those things?
No, I understood it.
Okay. All right. So, is there anything I can help you with?
I'm good.
You're keeping up on everything?
Yeah.
Okay. All right. Okay, then we'll be back here next Monday. Follow the, check my math lab for all your deadlines and keep up with those things. We've got a new quiz up, or a couple new quizzes and a test up there, so make sure you get those. And we'll see you next week.
Okay, thank you.
All right, thank you.